Hi, welcome to this tutorial where we're going to cover how to build an Arduino USB controller with a dual concentric knob encoder with push button and use it inside of the Garmin GNS 480 trainer for Windows. Pretty straightforward project, but it's specific to this. However, you could easily modify this for other things. Hope you enjoy it. Lots of ways to do this same type of thing. The prop wash ones that I order for some of the other projects that I build, they come like this. You end up putting it together and it looks like this. It's a little PCB board and you can put standoffs. Now, the standoffs are great for prototyping because you can use these nice little cables that have slide-on pins. They slide in, makes life easier. Now, when I did this one, this is why I use it for prototyping, is because as you can see, I put it on the bottom side. So I just use this whenever I'm prototyping anything as my use. Yes, I could remove the pins and start over, but I don't care. Anyway, soldering is not hard. Anybody can do it. You have to solder the encoder onto the PCB and then put in the pins if you want to use pins. Now, if you want to solder cables directly into it, thus minimizing the profile, away you go. If you use the pins, these cables come with all kinds of Arduino sets, and you can buy them separately, so it's not a big deal. But even if you use these, you'll notice that it doesn't really raise the profile that high. So you could choose to stay with the pins, which could be helpful when you're going through it afterwards, just because it makes life a little bit easier to just swap the cables if you don't want to reprogram the Arduino. Alright, I'm using a breadboard and I'm plugging in my cables. You'll see here this is using ground, pins TX0, RX1. This is your pins 1 and 2. We want these because they are capable of interrupts. Then we skip to ground, so really these cables could have come over here to ground, doesn't matter. These two cables on the inside, that is pin 2 and pin 3, and literally the silk screening on the Arduino shows you the pin numbers. Randomly using any pin you want, so in this case pin 8 for the push button. You can use anything you want. You can use 9, you can use 10, you can use 16. Use whatever you like. The only reason why I left a blank is some of these pins can also be repurposed as analog pins. So when you make a larger sketch that uses the keypad function, you need the analog pins and some digital pins, and then it makes a grid, kind of a selection where the analog tied to a specific digital pin will generate a button press. So it allows you to kind of connect multiple digital pins and multiple analog pins and turn it into a giant grid array. And what that does for you is with fewer pins you can get more buttons. For this purpose, we're not even bothering. So we're taking keypad.h out of it. By the way, .h's are not sketches, those are libraries. Anyway, moving on. In the real one, you might want to put some epoxy on this just so that the cable sitting in the box doesn't flex and break it. Your choice. All right, I'm gonna put that aside for now. This is how one would come from prop wash. As you can see, the pins, the boards, you get to decide how you want to do it. Pretty much you're gonna put that board onto the encoder because it makes it easier to get at all of the pins if you want to solder it directly with wires. Now, there are two Arduinos you can use. Your Arduino Leonardo, and again, there's Key Studio, there's tons of different vendors. You're looking for what they call the Leonardo, or you're looking for what is called the Pro Micro, or the Micro. Do not get a Nano. Do not get a Nano. The reason why these two work, and this actually shows up in the Arduino IDE as a Leonardo, is these are using the 32U4, which has a direct USB connection. The other ones use a serial chip, so you'll see that's only the one main integrated circuit, or IC. That's important because that means if you have the other chip on the board, you don't get the direct USB, and it has to go through a fake serial port, and it's a whole other pain. This is the easiest way to do it. The reason for recommending this one is if you can use one of these little project boxes, that guy's gonna fit inside, that guy's not. Now, obviously you could go with this guy and get a much larger project box. The benefit to this one is obviously it has more analog and more digital pins available at all times. For this purpose, we need something very simple. So we're gonna use the smaller one so that it fits in. Now, I soldered the pins that came with it onto it. So you can buy these. Usually they don't come with the pins in them, specifically because you may want to hard solder the wires directly yourself so that the wires can be soldered from this directly onto this PCB. Thus, less connectors, less problems. And also a lower profile so you can hot glue it down or do whatever you're gonna do with it. By the way, you can hot glue these things, don't worry about it. You could also use something like this where you can populate, and this is meant more for a nano, hence more pins, but it'll still work because these directly relate to the sides, so go ahead and use it. That's not gonna match exactly what that matches, so just make sure you count it out. The benefit of this is it just makes life easier. You could click it in, you can use the small screws, put the wires in, and now you're in a terminal strip environment. So if you just want an easy way to prototype it. One of these boxes, it'll be tight, but it'll fit. The screws, everything else. So if you put that in, you close the lid, it'll fit. What we would do is crazy glue it down, and then you'd be able to get your pins and then just use hot glue to affix it to the surface. Because what we're gonna end up doing is we'd wanna take this guy and mount him inside of it with enough room for everything to go. That's why I say, if you don't solder the pins down, and you just put this in the box, flat, solder the cables directly, you can hot glue it in place. But again, that's why you want to put epoxy to reinforce. Don't put the epoxy on this until you've put a micro cable in, otherwise you'll run into some problems. If you're gonna do it and apply the epoxy, make sure you put the cable in, then apply the epoxy. 1/4" drill bit. So 1/4", done. So another option, use this to prototype, get your sketch, make sure everything works, since you can plug it in and you can just seat the wires in here. Meaning solder the wires direct onto here, seat the wires in here. You can make sure the sketch works and everything functions. Then when you're ready to put it into the project box, if you don't want to solder directly into the Arduino, or if you've already got the pins set up because you did something like I did, you can also buy these. So these, pretty cheap, and the benefit of them is the Arduino is going to sit inside and off the sides, so it'll jump the middle, you won't have to worry about those, but off of the sides of that, anything you put in. So you would put the Arduino in the top, put the wires through the top, flip it over, and solder from the bottom. After it's done, make sure that you take those pieces off. That slides through the opening hole, right? So then you're able to attach your threaded items onto it. Depending on how thick your project box is, you may need to clear out some of the excess inside to make it fit. But essentially, that slides in, and you use those pieces. If you did it on the top or the bottom, it depends how you want to use it. And then you take a notch out. Now, rotozip anything you want. You could always drill right on and shred it, right? So use your drill and shred down. You just basically want a notch so that the USB cable will go inside. You'll take your nano, put the nano inside, stick it down, hot glue it. That guy is coming through. He's inside, hot glued. So, because you've soldered the wires, hot glue it, wires directly in, away you go. Then you can stand it up, use double-sided tape, a suction cup, stand it up. Now you've got your knobs. And what's nice, and for 12 bucks, come with a knob. Let's go to the Arduino website. It's arduino.cc. Arduino.cc. Alright, so software, downloads. Let's go for the Windows installer. Give them money. Alright, download, save it, done. In our downloads, we should have the Arduino installer. Double click on it. Now that it's installed, go ahead and download the sketch as needed. Go ahead and extract it. If it showed up as a zip, you need it as a folder. So we're going to extract all. Now, sometimes it does this, where it puts it as a folder in a folder. So if that's the case, then leave it like this. Go over here to another finder, go into documents, go into Arduino, and right here, drag and drop it in. And then we are going to close off our downloads. We are good with that. We're going to go into the V3, double click on the V3. Make sure that your Arduino is plugged in. Go to Tools, Arduino Leonardo, pick it, it'll show up. So here it's COM 6, which is virtual COM port. I can get the board info and I can see the vid and the PID. Life is good. And then go ahead and upload our sketch. You'll see blinking on the board, and it's done uploading. Read through it. I've showed you the wiring before, but essentially you're putting the first two pins, the 0 and the A, to a B and an A, ground, and then pin 2 goes to the other A, and 3 goes to 3. That's all you got to do. Then you want to wire up the button to pin 8 and another ground pin, unless you've commoned all the ground pins together, which is also possible. Why did I pick pin 8? I picked pin 8 because it leaves room if I wanted to do 2 encoders, because of, say, a GNS 430 or 530 instead of the 480. Button pin is 8. If I was going to build this with 2 of them, I'd have button pin 1, button pin 2, and then duplicate all the other code. The prop wash encoders use half step. We use keyboard.h, which is included, so we don't have to worry about it. We are using pull-ups because we're tying to ground. We're doing 2 rotaries because it's a dual concentric knob, meaning it has 2 rotaries on the knob. Here's how we define the structure. Here's how we build the structure. Pin 0, pin 1, button 25 and 24. This is to do with keyboard or joystick stuff. We don't care. Just fill it in this way. If I add more, follow the same structure and enlarge it. Here's the code from Ben Buxton. This is the best encoder code I found, best way of doing it, and I'm very happy with it. Get it in my setup. I'm going to pin mode, button pin, input pull-up so we can short it to ground, and then call the rotary initialize function. When we get to the loop stage, we are checking and reading the button. If the button's down, we are writing ASCII 32. ASCII 32 is the spacebar, delay 50. That is because the cursor in the Garmin trainer uses the spacebar for the cursor. Else we do nothing, and I left the delay just as an entry. It's a placeholder. Then it checks the encoders, and then it'll start the loop over. Here's your initialization for the rotaries, setting the pins to input and input high. And then we've got another function, which is the rotary processing, which gets called inside of the check all encoders function. And so here we do our checking of our encoders, number of rotaries, and if it's rotary 0 and it's counterclockwise, send the up arrow. Else, if it's encoder 1 counterclockwise, send the key left arrow, key down arrow, key right arrow. Okay, so now that we've done this, it's important to understand this part of it, because depending on your wiring, if things don't go right, if you've soldered the pins and you didn't use standoffs that you can just swap the pins and move the encoders around, you'll instead need to change which command each pin is sending. Here we are, and now taking our knob, we may have things backwards. So when we go and look at keyboard mapping, the left arrow key should be small knob counterclockwise, and the right arrow is small knob clockwise, and then up arrow is the large knob. Alright, so these may be backwards right now. Easy way to figure this out for me, click here on the big one, and I can see the big one should change the map. Okay, so I click the big one, and that's changing the range. And inside of the GUI, I click the small one, and that's the range. Here I'm clicking the small one externally, and that's the map. So it looks like I have them backwards. So what we'll do really quick is come over here, and we'll say key left, key up, key right, key down. Quick save. I'll upload. Life is good. Let's hop over here now. And now the little knob is doing the range, and the outer knob is doing the maps. But my range is going backwards, and my maps are also going backwards. Now what we've got is that should be right, that should be down, that should be left, and that should be up. On the save, click on the upload, and the Arduino is done programming. So now I'm clicking on the small knob to the right, and right goes up, left goes down, and now using the big knob, we move to the right, and if I turn it counterclockwise, it moves to the left. Click on it, that's the cursor button. So everything is working perfect, and all of the clicks don't have the sudden jump left or right that's used in some of the other libraries. So this is by far a much better implementation. And as you can see with the Garmin 480, it works great. So again, it's really simple to do. Just get yourself a Arduino Micro, prop wash, little encoder box, and project box, and you're good to go. So any questions, hit me up either in the comments here or in the 480 group, either way, and I'll try to do my best to help you guys out. But this should be all that you need. Download the IDE, drop this sketch in, flash sketch to your Arduino, and you're good to go.